Hello, and welcome to the first tutorial for learning C for cybersecurity. In this tutorial, I will show you how to begin programming the C programming language. Why learn C for cybersecurity? C remains a heavily used language in systems programming everywhere. Our programming languages, operating systems, to vehicles as complex as digital military defense continue to be developed in C. Since C is the language of operating system development, it remains the lingua franca amongst developers. Despite its omniscience, C codebases suffer from more security flaws than any other language used in production. Cybersecurity professionals everywhere are expected to be able to identify such vulnerabilities in C codebases for this reason, and recommend the necessary steps to avoid them in development. So if you're a person that's interested in cybersecurity, why would you use this tutorial compared to the others? With so many books and YouTube channels dedicated to teaching C, why this one? Some books mainly focus on syntax. Those just make you good at grammar, like C Primer Plus. Not problem solving. Fewer do a great job of teaching pointers, like Pointers on C. Get this book, by the way, it is so worth it. Even fewer discuss how to avoid common security bugs, like C code, secure coding, and C and C++. You will not be trusted with deploying software in C or other C-based languages until you master pointer manipulation. You will not be trusted on a security project unless you can audit code bases based on the C language. College courses and industries have fallen short of the responsibility of teaching their students and employees secure coding practices to avoid common security bugs in C and C-based languages. If you are reading this, you are probably a college student disillusioned and frustrated with the lack of care your university put into teaching the language. Yet the other YouTube channels that cover these topics in depth, I find, are hard to discover in the first place, or do not offer exercises even if they do. And even if they do offer exercises, the courses are outrageously overpriced. I kid you not, some of these courses can end up being over $100 just for a 3-hour video lecture to as much as $339 per year. That's an insane price. So, out of frustration, I made up my mind to offer this comprehensive tutorial series covering the entirety of the C programming language, coding data structures and algorithms in C to help you pass your job interviews, and secure coding techniques used in the industry. By the end of this tutorial, you should know C well enough to begin research on how to use C for any security-focused project you wish. You should be able to identify security flaws in your and your colleagues' codebases and rectify this mistake as well. So let me go over the target audience. Anyone who is interested in developing tools for software security assessment, you can look up what that means in the link, will find this tutorial helpful in their coding journey. Software security assessment is the science and practice of identifying security flaws in codebases. If you are a security engineer that is interested in developing static analysis tools, formal verification tools, and compiler-based security defenses, this tutorial series should serve as an outstanding introduction to the C language. Each blog post will come complete with programming exercises and a complete solutions manual to help you check your accuracy. I'll talk about that more at the end of this tutorial. So let's begin. Some prerequisites. If you have not already, you should go through the effort of learning Java or C++, or even preferably Golang. Preferably C++ if you can handle it. If you do not, you will struggle quite a bit to understand this tutorial. Fair warning. Personally, I would probably choose Golang because Golang was invented by the original Unix developers that used to work at Bell Labs, so Golang is closest to C. Nevertheless, if you know C++, it's not a problem. You already know the majority of the syntax, although you may still struggle with pointers. A topic I will emphasize throughout this tutorial series. I assume you have experience using the GNU Linux command line interface. For those of you that don't know GNU Linux, it is an operating system that's well known and respected in the software development world. You should definitely take the time to learn it. In this tutorial, I use a specific operating system called GNU Debian Linux. I'm running it right now as I speak. If you do not, I strongly recommend you stop reading this and pause this video. Learn how to do that now first. You need to learn how to use Bash, and one great tutorial to do this is in the blog post seen here. Another great site to learn the Bash command line interface is ss64.com. Without Bash, you will struggle to understand how I compile and execute code. I chose these tools because they are a standard in the industry. Beyond just watching lectures, you actually need to practice using Bash. Install GNU Debian on your computer now and force yourself to do as many tasks as possible through the command line. This will force you to become proficient at using it. I also want to point out some other great references before I continue the tutorial. I strongly recommend you get a copy of any of these books, whether through digital edition, such as using Safari by O'Reilly, or by buying them from a bookstore. C Primer Plus, Pointers on C by Kenneth A. Reek. Strongly recommend this book. Get it. And of course, also get the C Programming Language 2nd Edition by Brian W. Kernighan and Dennis Ritchie. Dennis Ritchie invented the C language, so this is a de facto reference. But Pointers on C will help you master pointer manipulation, a difficult topic. You should also get Fluent C, which will teach you how to write professional, production-ready C so that your colleagues can easily study user code, and so it's reliable on the job. Let's talk a little bit about compilers. The compiler translates your C source code into what's called native machine code. Those are the binary instructions your machine actually executes, that your CPU actually executes. You need a compiler to translate C into a form, into a language that your machine can actually run. Get the GCC compiler. It is an industry standard compiler, and it is the official compiler used to compile GNU Linux. For this reason alone, I recommend you install that. You can click on this link that I'm highlighting right now to help you install GCC. Next, you should choose a great editor. You should choose either Vim or Emacs. I could make a separate YouTube video on the futile debates coders had on which text editor for software development is better, Vim or Emacs. Most people start out with those glossy, gooey text editors that I'm not going to even talk about here. At some point, you're going to get ticked off that the editor slows down your development, though. Instead of worrying about using a GUI-based text editor, I strongly recommend you learn how to use a command-line interface-based text editor, another reason why you definitely need to know Bash. Vim and Emacs are both famous for helping developers finish their code faster, despite their lackluster appearance. They will look like text inside the terminal. It will look ugly at first, but you will very soon see how much faster you can ship code with the help of these editors. They are worth the time investment. They are worth the learning curve. I know. I've done hackathons with these editors and won them. I strongly recommend you learn Vim if you have not already. It will help you develop faster. Emacs is even more powerful for productivity, but it does have a larger learning curve. The reason why I recommend Vim first is that you can apply Vim keystrokes in Emacs, but of course you should learn Vim before you try Emacs, in case you don't already know Vim. Do not try to use the Emacs built-in keystrokes, unless you want to break your fingers. Several famous coders had injuries thanks to Emacs' keystrokes. If you get Emacs, make sure you are in evil mode to benefit from the Vim keystrokes. It will save your fingers the hassle. And if you're serious about using Vim, install it in your GNU Linux environment, and then see the tutorial that I'm highlighting right now to get started with Vim. It's an online website that trains you on how to use Vim. Writing our first program, Hello World. Let's make our first C program. Don't worry about understanding what it means. The whole point is to teach you how to write, compile, and execute C programs. I will assume you already know Bash at this point, so let's begin. This photo shows me in the temp directory, which is what I'm doing right now here. I am going to create a new file using Vim right now. I'll do it slowly. Vim hello world.c. Once I finish typing that, I'm going to press enter. I am now in Vim inside my command line interface here. I'm going to now type in the following manually, and I'm doing this because I know beginners have trouble with the syntax of a new language. It's a common, normal thing, nothing to worry about. Definitely something where it'd be helpful for you to actually manually type through on your own on purpose, so you start learning the syntax of the language. So please follow along with me and start typing in Vim as I do it myself. I am just going to quietly copying the entire text. I'm not going to even worry about what it means on purpose. We just want to make sure that you got the syntax well enough to the point where you can compile this. I'm trying to show you how to actually build an executable. That's what matters now, not what it means. Note the end curly brace. Vim actually points out to the curly brace and highlights the opening curly brace for you. Once you have copied the Hello World C file, go ahead and type in :W, as seen here, and press enter. This will save the file. Now I'm going to type in :Q, as seen here. I will now press enter. Notice we have exited Vim. To compile our program, follow what the picture does exactly in your temp directory. I'm using a new shell called fish, so bear with me here. Highly recommend you figure out how to use fish. It's a better alternative to bash, I promise. So I will compile this now, as typed, by pressing enter. What just happened is GCC accepted our source code file, helloworld.c, that's our source code file. -o means we specify the name of the final object code, and an object code is a fancy name for the final machine executable file that our machine is going to run, which in this case is helloworld.o. We now have helloworld.o in our directory. And we execute it. We see the hello world string, as specified in the photo. Just to let you know, in the real world, developers compile several C source code files at once to build the final executable. But for this tutorial, I will keep it simple. Let us compile one file per tutorial for now. Now that we have compiled our C program to native machine code, we can execute it by doing the following in bash. As done in the photo. My bad, sorry. We already went through that. Let's break down how this program now works. So preprocessor directives. I'm going to open up the file once again. Notice this line, hashtag include standard input output.h. That hashtag does not mean what you think it means from social media. What it really means is that it's a preprocessor directive. It is a flag for the compiler to tell that it needs to do something. Include basically means the compiler needs to import all the content of a file, standard input output.h, and paste it, replace in this line with the contents. When the compiler reads this line, it replaces the line with the contents of the file known as standard input output.h. In the C programming language, files that declare the C library functions for an API are called C header files. Header files usually only contain the function's declaration, which shows the function name and set of parameter arguments, as seen below. This does not include the function's definition, which is the code that the computer executes when the function is invoked in the call stack. So as I said earlier, for example, the printf function, a function that we just recently used in our program, the following is the printf function declaration. Notice that there is no code definition, as you would expect to see in the curly braces below. That's because it's a function declaration. We're simply explaining to the compiler what the parameters of the function are and what data type it returns. We're not explaining to the compiler what the function does. To help you understand and hashtag include better the preprocessor directive, you can try the following exercise right now that I'm about to show you. Follow along with the photo that I have here. So what I'm going to do is, I'm going to paste the entire contents of the actual file, standard input output.h, into a brand new C source code file that I'm going to call hello world standard input output header imported. Let me show you what that did. As we can see here, what is contained in this file is the entire contents of standard input output header file, beginning with a hashtag if not defined preprocessor directive. Another directive you will see later in the exercises. But for now, just look at the contents. These are the contents of standard input output header file, all pasted into the hello world standard input output header file imported that I made up. And this file line 911 ends standard input output header file. That's the only thing in this file right now. What I'm going to do right now is I'm going to now define the main function on purpose. And just like last time, we're going to print hello world. You don't need to worry about what's inside main for now. Just be aware that I just pasted the entire contents of standard input output header file at the very top of the file first before I define the main function on purpose, just to make sure that the library is imported without using the hashtag include preprocessor directive. I'm now going to exit. A little bit about standard input output header file. It is a standard C library, meaning you should be able to use the library in your C source code immediately after installing GCC. Throughout your days coding in C, you'll often be importing C standard libraries such as C standard input-output header. A great website to learn how to use C standard libraries is n.cppreference.com. This is an outstanding resource my university professor showed me, and it was such a good resource I still use it to this day, and I highly recommend it for you. Please pause this video and visit this website now. It is a lifelong reference. Here is a link in the blog post to the page on n.cppreference.com for standard input-output header file. And here's another link for printf, the function that we are talking about now. Pause this video and take a moment to read these two links. It's worth the time. And with saying, let me go back to talking about what the main function actually does at long last. So about the main function, let's take a look at the following line, int main void. For experienced Java, C++, and Golang coders, that int should be familiar. What this represents is the data type that represents the data type of the value the compiler expects main to return. Int is a signed 32-bit integer. That means it takes up 4 bytes of memory in a 64-bit machine. These values, the lowest value to the maximum value, these are the standard values a signed 32-bit integer takes up in any language. I mean, in Java, C++, or Golang, my bad. Some languages actually don't operate like that, but that's besides the point. Since the main function begins with the data type declaration int, the compiler will expect the coder to return a value of data type int at the end of main execution. If you don't, the compiler may throw an error or at least a warning. In C, the main function is the first function the machine will execute. It is even required for proper compilation, and this is the same grammar rule that Java and C++ have. They inherited this grammar rule from C the entire time. To demonstrate that, take a look at the following code in the photo. You don't need to worry about what it means. Just know that the main file doesn't exist in there. When we try to compile that, notice it screams error and that there's no reference to main. You need to put in a main method in at least one of your C source code files, or the compiler will fail to compile your code. It's mandatory. I will say that a second time. Let's now take a look at another part of the function declaration, void, within the parentheses of main. This tells the compiler we do not want coders to pass any arguments to main when invoking the main function. If you do, the compiler will throw an error. And now let's take a look at those curly braces. Now I highlighted the curly braces to make it obvious that I'm paying attention to these. Just as in C++ and Java, those curly braces define the boundary of the function definition. Any variables defined within the function definition that is assigned static memory will automatically be deallocated and inaccessible after the function call returns. This is the same grammar rule in Java and C++. I will repeat that again, as well as Golang. The printf function, let's discuss that. In C, we expect coders to use the printf function a lot to format strings and print them. It's coding convention, and printf is an exceptionally good print function to format how you print strings. I used to use println in Java. When I learned printf, I immediately threw away the idea of using println and immediately switched to printf. It is that good of a resource. The printf function, like I said, is the standard printing function C coders use. It has its pros and cons. The best advantage of printf, as I said earlier, is that it is very easy to format the final string that is printed, especially when you have to print a message involving values of several different data types. I will discuss the downside of printf in a future programming exercise. And let's take a look at the argument in printf. %s. That percent sign is not a percent sign. It's the format specifier. So %s, or format specifier s, tells the compiler we wish to print a string. The compiler will then expect a string argument right after the first argument. So I'll say this one more time. The first argument in printf is the format string argument. You may specify %s in the first argument of printf. You may not do this in the second or third or any other further arguments down the line in printf and expect it to render that %s argument in the second, third, or fourth arguments properly. You have to specify %s in the first argument properly, or it won't render the future strings, replacing the %s in the format string with the actual string you were trying to replace it with. We can ask printf to print more strings by playing with the first argument, which allows us to tell printf how we wish our strings to be printed. Below is a nice example. Let me do it myself. At this point, the alignment is a little off because I am splitting the screen here between the terminal and the blog so you can follow along. In the modified code above, we see a second %s string argument. I will say this one more time. You may not use format specifier string arguments in anything but the first format string argument here. If you try this in the second or third arguments, %s will not be properly replaced in the second or third or fourth arguments with the future strings you specify in printf. Only do %s inside the first string argument. I am warning you. So in the modified code above, we see a second %s string argument in the first argument for printf. This tells printf to expect a third argument that is also a string. That third argument is the string. This is the second string in the line. This is the second string in the second line. This %s is going to be replaced with this, but this %s is going to be replaced with this. We don't always have to specify extra %s string arguments in the first argument of printf. Another way of doing the above is shown below. I'm not going to write that out. Notice the second version of the printf looks a lot messier than the first one. Please consider using printf properly. It will make your developers' lives easier. It will make it easier for everyone to read what you did. I will go ahead and compile this just to prove that the string works. I notice it doesn't have the second line because it didn't bother copying this, but that's okay. You can do it on your own if you want. In the above highlighted line in figure 15, I replaced the second %s string with the actual string it was specifying for. I admit this code looks more ugly, but the point is the first argument in printf is just a string. Anytime you see a substring in the first argument to printf that begins with a % flag, let me go ahead and type it in, % flag. It is a format specifier for a value of certain data type. %s just specifies yet another string that is expected in the next argument in printf. I will later show you more format specifier flags you can use to print more data types, especially the primitive data types. For now, I will turn my attention to return status. Why it's important. So the final line of code in main is shown below, return 0. What that does is, it tells the machine to end the main function call with exist status number 0. This will help coders tell if program execution completed without error. With the above statement, you can easily check if your program completed without error by doing the following in bash. So let me go ahead and try that myself with this code. I am now compiling. I am now going to execute the code. Let's check if it got a return status of 0. Success. Return status of 0. Just like in the photo above, I check if program execution completed successfully by applying the echo status command. Since we see that 0 has been returned, we know that our program worked without any reported errors. And now, having explained printf, I will explain more primitive data types that we can use with printf. We have already seen our first primitive data type, int, and technically we have seen our second primitive data type, strings, and we know the range of integers we are allowed to represent of that data type, int. There are several more. If you are experienced in Java or C++, all of the below should be familiar. Take a moment to pause this video and just look at this diagram. These are the primitive data types. These are the format specifier flags you have to use in the first argument of printf only. You're only allowed to use these format specifiers in the first argument of printf. I will say that a third time even. This is the size of memory that each data type takes up when you assign a variable of that data type. And these are the range of possible values you're allowed for each data type. I highly encourage you to pause this video and take a good look at this diagram. The link to this blog post is in the description for this video. Please see it. The format specifier for long and sign long is %LD. I'm pointing this out because this diagram doesn't contain that information. For those of you familiar with C++, you will be familiar with this. For the rest of you, just hang on. Pay attention to these data types and keep them in mind. Get familiar with them. The format specifier for unsigned long is %LU. The diagrams above explain most of the primitive data types, though not all of them, with the exception of pointers, the format specifier used by printf-based functions to print such variables, the size that indicates how much memory the data type uses, and the range of valid values for each data type. I pretty much showed every primitive data type except pointers on purpose. We will worry about pointers much later. Not yet. Let's take a step back. Why do half of these primitive data types start with the reserved keyword signed, like signed car? To understand why, let's compare signed car versus unsigned car. Notice the only difference between the two are the valid range of values for each. Unsigned car has twice a larger range of positive values than signed car does, despite taking up the same amount of memory. In signed binary representation, the most significant bit, or the leftmost bit in a bit vector, is used to represent whether the number is a positive or negative integer. A most significant bit of 0 for a signed binary number means the number represents a positive integer. A most significant bit of 1 means the number represents a negative integer. To help make this more clear, please see the below photo that compares the binary and numerical representations of an unsigned car versus a signed car. In this tutorial, I will skip exploring the signedness through binary form on purpose. I want to start slowly with primitive data types. For now, just try to observe what I said carefully and do your best to understand it. I won't test you with exercises on this just yet, on purpose, though. Notice unsigned car allows for a larger range of positive values than car because the most significant bit actually is a part of the binary encoding, but that's not the case for signed bit. Remember that. In the signed case, remember, the most significant bit represents the signedness of the value. In this case, it's a positive value. If that were a 1, it would mean that car A would be storing a negative value. I would now like to take your attention to the following code sample, where we practice initializing and printing each data type. If for experienced Java and C++ coders, most of the syntax should be really clear. Allow me to explain these symbols. So whenever you see a max, know that that's a constant value that represents a number. And as the name implies, it represents the maximum possible value for that data type. You can find the full definition for these constants in the standard library limits.h for integers. There's a separate library for maximum and minimum values for floating point numbers in a separate library. And that is an exercise I will literally leave to you after this tutorial ends. Let me go ahead and copy and paste this. I will copy and paste it quickly. Print data types. I will save and exit. Compiling now. And when I run this, I get the following results. Let's pay attention to unsigned _ch for a second. What's up with this question mark? This weird question mark symbol. What that means is the machine is not sure how to actually display the integer that the variable represents. There is no encoding for it. The number that was stored in unsigned ch, 255, is not a printable ASCII character. That's why we see the question mark. ASCII is the standardization of what each byte represents for which character on your keyboard. 255 is the biggest number possible that you can store in an unsigned 1 byte variable. And the thing is, that represents the EOF, end of file byte. A byte I will talk more about in a future video, not now. Take a look at the decimal large double. If you paid attention to the actual definition of large double, should be somewhere right here. Here it is. 1.1 E300. Compare 1.1 E300 to what was actually printed. That is not the same number that we put here. I did that on purpose to illustrate a problem. In floating point arithmetic, it is normal for there to be a loss in precision when doing floating point math. This is why applications where correctness of arithmetic is crucial should never use them. Banking and financial applications avoid floating point numbers and instead use unsigned integer types instead. This prevents unnecessary loss of value. This concludes part 1 of this C tutorial. I did everything slowly on purpose to give you time to react and understand all the information I sent to you. I try to keep this tutorial self-contained and as simple as possible, though I understand if you are slightly confused about what I just said earlier. That's why I went through the effort of even giving you exercises. I believe I have... how many exercises? Ooh, 9. 9 exercises that are in the blog post in the video link to this in the YouTube description. So please, after you finish watching this video, click on the link in the video description and you will be taken to the blog post. The cool thing is, not only can you do these exercises, I also left behind a complete solutions manual for you to study and learn from your decisions in coding. You can check your work, and you can compare what you thought about these exercises compared to what I had to say. If you have any comments, please feel free to contact me, or just simply comment at the bottom of the blog post. For further reading, I strongly recommend you get C Primer Plus. It's a great book on the grammar of C, although it won't teach you logic or system design or any of the other things a security engineer needs. Another excellent reference is C, a reference manual, 5th edition. Again, a great book on grammar. And of course, if you want better references, take a look at the references I mentioned at the start of this video. It should be right here. I thank you for your time, and I hope to make another tutorial soon. Peace. If you like this video, please like, comment, subscribe, and click on bell notifications for more. I intend to make a brand new tutorial every week. Thank you so much for your time. See ya!